My name is Nathan Van Zenny, and welcome back to Catching Steam. Today it's all about density, and as you can see, I have a lot of different challenges for you. Some of them are a little spin on ones you've probably seen before, others are probably completely new. This very first one are just these 3D printed boxes. I see a lot of classrooms using these brass, steel, and aluminum cubes, and then maybe a wooden cube as well. They're all about this size, and then students are supposed to be able to calculate the density and then decide if they're going to float or sink. Well, most students just know metal sinks, so it's not much of a challenge for them just to be like, well, those three are going to sink, the wood's going to float, I'm done. So in this case, what I did is I made these 3D printable cubes, and then you can add as much weight in them as you want. Now these cubes are 3 centimeters by 3 centimeters by 3 centimeters, so the volume is 27 cubic centimeters. So if you know much about density, you know that if this weighs less than 27 grams, it's going to float. More than 27 grams, it's going to sink. So what I ended up doing is I made a whole class set of these cubes. They can just fit inside a Ziploc bag. And I added different amounts of weight to them. And then I super glued these shut. And then I labeled what number they are. And now I have a collection of these cubes. So I intentionally made a lot of them right around 27 grams. Some in 24, 25, 26 and a half grams, and then a little bit heavier all over the place. And then this ends up working out really well because now these students, they can practice calculating the density. I'm going to make a few recommendations if you want to go this path. And if you don't have a 3D printer, I do have some other recommendations for you as well. So I'm going to recommend that you get thin super glue. Take this cube and you'll notice that there's a little bit of a seam there. Unless your printer is absolutely flawless, there's going to be a little bit of a gap. And you're just going to let that super glue go right into that seam and then just kind of let it, pour in there and fill up that seam and then let it dry. And then after that, I typically go through and do it one more time just to make sure there's not going to be any water coming into this. And what I use for weight is typically I'm going to use kinetic sand. And the reason why I like to use this is you could use anything. It's just I don't want to turn these into rattles and just be listening to students doing this all class period. So I wanted something that is going to make a lot of noise. I've used washers as well. So these work fine as long as you either hot glue them in there, maybe wrap them in a paper towel, or if you want them really heavy, want these cubes really heavy, you put a few of these in there, put some kinetic sand in there, and then it's not going to move around. I'm going to make them all different masses, about half of them less than 27, about half of them more than 27. You can try and get a few of them that are, right at the density of your water so they don't float, they don't sink, they just kind of dance in the middle. That's a fun challenge as well. But then after that, that typically takes 1 to 2 class periods for them to calculate the density of all 16 of these cubes. In my case, you can have as many as you want, but they'll do a density of a cube, so they'll weigh it, calculate it, and then they go up front and they swap it with a different one. And then all the students are doing that until they get all the numbers. I also have some different sizes. So I have the smaller one here, I have a little bit larger one, and then I have one a little bit bigger yet. So I have a total of 4 different sizes of these density cubes, I guess. These ones aren't cubes. So, and then you can kind of use those however you want. What I've done is I will have a few of these extra. And then so when they finish all of these cubes, I'll have a couple different sizes, and then they have to actually measure these pieces and then calculate the volume and then figure out the density from there. This one, they're all the same volume, so they don't have to measure each of them. These ones, they would have to do that. Then from there, the next class period, we will essentially go over each number and decide if they float or sink. So I would say, hey guys, this is number 7. What did you get? Did you get it's going to float? Did you get that it's going to sink? Students say, hey, I think that, according to my calculations, it's going to float. I put it in the water, and good job, you guys got it. And then it's like, hey, 14, what do you get? Okay, yeah, you got sink, and you're right. So we just do that for a class period, and then you can also add in these ones too, the extras, in case students got to that. And now, I also have, if you want to do this challenge as well, I have another set of these cubes, and you can print off any shape you want, but have a whole other class set, and they're empty, and they're not going to ever get glued shut. And students are then going to add my challenge that I gave them is to add as much weight as possible without these cubes sinking. And I say they need to float for about 30 seconds. So then students, they make them, and I say whoever has the heaviest one that doesn't sink or heaviest one that floats, they win. So then all these groups, they all have their own cubes, or you can have a different shape. So one that they haven't done yet, so they have to calculate the volume. And if you want, you can give them all the shapes. You can give them all 4, and then you can say, hey, all 4 of your pieces have to float, and then the heaviest ones out of all 4 of those, you can throw them all on the scale. Say, hey, this one weighed 100 grams, this one weighed 97, the 100 grams wins, if you want to do all of them. So however you want to do it, but there's a lot of different challenges. You can push them beyond that. Now, if you do not have a 3D printer, I still have a recommendation for you. They sell these pieces of wood called pin blanks. And nice thing is all these types of wood have different densities. Some of this wood will sink. So like this one here, that one sinks. Some of them float. And then students can then calculate the density of that. There's another option. You do not need a 3D printer. You just have lots of different types of wood, and you can look ahead of time. You can print off the list of the densities of wood. Ones that have a density higher than 1 will sink. Ones that have a lower density than 1 will float. And you can even find some that will kind of hover. They're right at that, about the same density as water. So they will get these blocks, and then from there they can measure the volume, measure the mass, and calculate the density. Now, some recommendations I'm going to give you to make them more waterproof or water resistant. And you're just going to take some super glue, put it on a paper towel, and rub it onto these pin blanks. And you're going to do a few coats of that, and then that's going to really soak it in and essentially make the exterior of these blanks plastic. A beautiful part of these as well is they're all about the same size. You can cut them to different lengths, so I can get one pin blank and cut it into 3 or 4 sizes, or 3 to 4 samples. So that way you have 4 of this one, 3 of this one, however you want to do it. There's also these pieces of wood called knife scales. They're for like a knife handle that woodworkers will put on there and make them look nice. It's just a different shape, and they're all relatively inexpensive. If you have a local woodworking store, not a hardware store, but a woodworking store, they typically have a lot of these for, $1, $2, $3, sometimes $5. Really, really nice ones can be more. Okay, this next challenge is definitely tougher than the last one. This is called the King's Gold Challenge. It's loosely based off the Eureka story. I looked into it. Turns out that story likely didn't happen. So I kind of make up my own story loosely based on what that one is. But I'm going to kind of walk you through the setup here. But my favorite part about this challenge is it gives so many opportunities to talk about the scientific process and trial and error and just being able to modify your experiments to make them better and better. So I'm going to kind of walk you through what that looks like in my classroom. If you really wanted to, you could tell them exactly how to do it, and you could be done in 1 class period. Or you can make it take 2 or 3 class periods and have them learn that process of what scientists do to make their experiments run better and better. So here's the concept. I tell them that there is a king, that he believes that the jewelers that he's giving gold to, they're taking some of that dense gold and replaced it with some less dense silver. And he can't really tell from the looks of it, but he's a little upset that they're taking his gold. And they're making crowns or unique shapes that he can't just easily measure. He doesn't want to melt them down into cubes to make it easier to measure. He thinks they're beautiful. He just wants to know if he can trust these jewelers or not. So the king is giving you a sample of gold. And I actually have a bunch of the same color, and I'll kind of explain why here in a minute. So this is just a balloon with a bunch of kinetic sand in it. And you can do regular sand as well. You can do Play-Doh, anything that's denser than water will work. Then I wrapped it in a balloon, and then I super glued the knot so it doesn't come untied. So the gold one, I told them, is the sample of gold. This white one is from jeweler number 1, and this one is from jeweler number 2. Now, what I did to set this up is I had all of the pink ones in this case. They're filled with the exact same thing as this one. They're the same exact thing. So I fill it with kinetic sand, fill these with kinetic sand, tie them off just the same, and you should be fine. This one, what I did is I put a little bit of styrofoam inside of this ball. So I have a bunch of kinetic sand and a pretty big chunk of styrofoam in there as well. So this one is less dense. So now students were able to figure out the density. Now, if you just feel them, you can't really tell. If you just weigh them, you can't really tell because they're all different sizes. They're not all the same volume. So the challenges here is they had to figure out essentially how to measure the volume of these weird shapes. So they're going to have 2 cups here. They're going to fill 1 cup up to the brim, and then they're going to have this sitting inside of a larger cup. They're just going to take the sample and lower it into the cup and then have it overflow. This one should be the most dense. This one, we know, should be the same. This one should be less dense. I'll tell you right now, they will not get that. They're going to mess up so much, especially on this volume part. So by the end of class, I'm kind of pointing out that, hey, we're messing this up a lot. So it's like, hey, we're going to see if we can figure out something in the next class period. Next class period, what I do is I have students set their cup up, and we're just going to do the volume. We're going to see if everyone gets the same volume. So group 1 will set up their cup with their water and everything. So does group 2, 3, 4, however many groups you have. Then you're just going to walk to each group and say, okay, here's the ball, and go ahead and drop it in there. Water overflows. You take the cup out, you take it back out, and you go to the next group. You just go through all the groups. You're doing the exact same thing. And they'll most likely all get different volumes. And then you talk, why? Why did you all get different volumes? Well, it's mostly because you all are filling this full, but full looks different for everybody. One thing that students may recommend is if you drill a hole in the side, you can have like a hose coming out, or a little tube coming out, and then you can just go until it overflows. That goes into a different container, and then you just move the hose into a separate container, lower this in there. That would be optimal. I didn't want to do that and drill a bunch of holes in all these cups. So what we decided to do as a class, and the beautiful part, I didn't even come up with this, is my students. So what they decided to do as a class is they filled this cup up to full. We decided what full looked like. This obviously isn't full, but we filled it up. The whole class agreed, yes, that looks full. Or, hey, we need a little bit more in there. Okay, oh, that's too much. Okay, that looks full. So then what I did is we took this water and we poured it into a little garage wood cylinder. And then we're like, hey, that's 50 milliliters. Then this is 100. And we just kept emptying this until we figured out how much water was in this cup. So let's say it was 272 milliliters. So then what we did is we said, okay, everyone now needs to fill their cup up to 273 milliliters or 272 milliliters, whatever it was, every single time. So then they're putting this empty cup in there, and they will fill this up 50 milliliters, dump it, fill it up. There's 100, 150, 200, 250, and 23 or 22, whatever it is. So now students are learning like, hey, we're all doing the same thing. And then some students were dropping it in there while some students were slowly lowering it in there. So we discussed as a class, what one's more accurate? The best part about this is after we started doing this, I had students jumping up and down excited because I calculated the densities and they're the same. And it was mainly because they were a part of that process to be able to modify it and fix it and improve it. And once they saw that they developed a process that worked, like, yes. And so that's what I really liked about this. Now, after you end up getting a good process, measuring the mass and getting the volume, most students, most groups figure out that this jeweler was robbing them of gold, while this one was not. That was their evidence and reasoning, and then they essentially recommend to the king to keep using this jeweler and not this jeweler. Now, this one I'm going to take a very common demonstration, and I'm going to turn it into more of a lab than a demonstration. So the demonstration I see is, here's a picture of one, but just these density columns where they have all these different liquids. Sometimes we'll put some solids in there, and you can see all these layers floating on top of themselves. It's cool. You know, it's a nice little demonstration of, density, but there's a really awesome way that you can turn this into an actual lab. And here is my recommendation of doing it. So you can get any type of tube or container. Just make sure all the containers are the same. I just found these ones. Now, what you're going to do is you're going to take each material that you're going to use. In this case, I'm just using 4. I'm using this corn syrup, vegetable oil, 5W30 oil, motor oil, And then I also used just some water and I dyed it red. So just some food coloring and some red water. So what I did here is I had these 4 samples and I poured different amounts. And so I took this vegetable oil and I poured it into 4 of these little tubes. And then I super glued, yes, please, super glue these lids shut. So then I added some super glue in there, screwed it on there. I added some more super glue in the lip, and then it takes a while for it to dry. So after that, I did that to 4 of them for this one, 4 for this one, 4 for this, and 4 for the water. So I had 16 of these tubes, and then I labeled each of them. So I just said all the red ones were A, and I labeled this tube 1. The next colored water one, I labeled A2, A3, A4, and did the same thing for these. So what students have to do at this point is they have to figure out what the density of all these liquids are before I pour them all together. They can't open this, so I do not let them open it. From here, what you're going to do is they're going to have an empty one that they get to use. So this one, they're going to weigh it. Okay, I found out what the mass is of the liquid plus the container. And then I need to weigh an empty container. So now I have the container itself, and then I'm going to subtract these two. So now I just know the mass of the liquid. Now after I do that, I'm going to do some indirect measuring, and I'm going to pour some water into this one until it's to the same level as this one. So now these two are the same height, so I know these have the same volume. I'm going to take, oh, this lid didn't need to be on there for that. So I'm going to pour water into that. Then I'm going to take this and pour it into my graduated cylinder. And now I know that the volume of the liquid that was inside here. So we have the volume, now we have the mass, so you can figure out the density. I have students do 2, if not 3 different samples you can decide. So I made 4 each that are in the front of the classroom. I tell them they need to get at least 2 of this one. And I also tell them the densities need to be extremely similar. Otherwise you need to do a 3rd one or a 4th one until you know what the density is. And then from this, do the same thing with this one, this one, this one. So if you said 2 each, then they would have to get 8 densities, and then they're essentially finished. They should be able to look at the average densities of each of them and figure out where in those layers each of them are. And then afterwards, you can do a little demonstration to see if they're right. So I start off with one liquid. In this case, I like to start off with water. So I pour the water in here. All right, now, so that was in my case, liquid letter A. So then I'm going to take this liquid. This is the syrup. And you can put them in different containers so they don't know what they are if you'd like. But at this point, I'm going to ask, all right, will this one go below or above the previous liquid? So this is liquid C. And then they look at their data. Okay, liquid C is more dense, so it should go below that previous liquid. So I pour it in there. And if you can notice, it is almost all entirely below the water. So it just sank right below where that water is at. So now we have the corn syrup, we have the water. All right, now the next one here is this motor oil. And you can do it in whatever order you like. I think it's kind of cool to be able to see them, go below. If you just go in order from heaviest to lightest, students may just believe. Most recent ones, it's going to stay on top. But you can see this went through the water, went underneath. And now I'm going to go with the motor oil. And again, I'm going to ask my students, hey, where would this one go? And if it'd be like, hey, according to my calculations, it should go on top. So now we're here. And you can see that oil is right on the top. So this vegetable oil should be able to go through the motor oil, but go right above the water. And now you can see it's making that line right where I said. So we have the motor oil, the vegetable oil, the water, and the corn syrup. So this is a cool demonstration all on its own. I just believe it's pretty neat to have students calculate the densities ahead of time, and then for them to be able to predict what's going to happen based off of their own experimentation and calculations. Okay, this last one here is going to be more of an engineering challenge. It's going to be a little bit tougher just for them to do strict math on it. Essentially, what's going on here is I have 2 syringes. You do not have to have this large of a syringe. I just like to use this for demonstration purposes. You can get any sizes, and you're just going to get a vinyl tubing that connects both of them. These are both filled with air, and I put some weight in this one already, so there's just some machine screws in there. I don't know if you can, and some nuts, bolts, washers, whatever you want. There's just some weight in here. Now, what it looks like is right now this thing sinks because it has a really high density, but then I'm going to push some more air into it, and then it comes up and it floats. So it sinks and it floats. So the challenge I like to give them is, what's the most amount of weight I can put in here and have it still come up and still rise? And what's the least amount of weight I can have in here and have it sink? Because if you don't have any weight in here at all, let's see if I switch these like this, no matter how much I squeeze this, this is never gonna sink, if you can tell. With no weight, it's not gonna sink. So what's the least amount of weight I can put in here and still have it sink? What's the most amount of weight I can have in here and have it still float? Again, nice little engineering challenge. You can have this as a math challenge. You have to be able to figure out the volume of this, the syringe itself, and then the volume of the air, obviously. And then they can figure out the mass of those with a scale. But last little challenge to give you, but between all 4 of these, or 5, depending on how you're counting, there's a lot of different ways you can have students experiment with the density. Hopefully you enjoyed this video, and thank you very much for watching.